Hello, explorers of the universe. Have you ever wondered what makes Jupiter so powerful? Or how stars like Betelgeuse shine so brightly? In today's video, we'll delve into some of the most fascinating facts about the cosmos, unraveling mysteries about planets, stars, and unexplained phenomena. This video will expand your knowledge, spark your curiosity, and maybe even change your perspective on the universe. If you want to better understand what lies beyond our world and discover secrets that scientists are still trying to unravel, then this video is for you. Let's start this cosmic journey together and explore the incredible mysteries of space. Jupiter is a gas giant that has fascinated astronomers for centuries. With a diameter of about 139,820 kilometers, it is so large that it could swallow all the other planets in the solar system and still have room to spare. Its main composition is hydrogen and helium, similar to the Sun, which makes it a star that has never managed to light up. Jupiter's most iconic feature is the Great Red Spot, an anticyclonic storm larger than Earth that has been observed for more than 350 years. This storm is so intense that winds can reach speeds of up to 432 kilometers per hour, stunning Jupiter, and its storms help scientists understand more about extreme weather systems. In addition to its own grandeur, Jupiter also has a ring system, although it is much fainter and less visible than Saturn's. These rings are mostly made up of dust created by meteors that collide with their moons. Speaking of moons, Jupiter has 79 of them known so far, including the 4 large Galilean moons, Io, Europa, Ganymede, and Callisto. Each of these moons is a fascinating world in its own right. Ganymede, for example, is the largest moon in the solar system and is larger than the planet Mercury. Ice-covered Europa is one of the best candidates in the search for extraterrestrial life in our solar system due to the ocean of liquid water believed to exist beneath its icy surface. Exploring Jupiter and its moons continues to be a priority for space science, with missions like NASA's Juno providing us with valuable data about the composition, atmosphere, and magnetosphere of our solar system's largest planet. Venus, often called Earth's twin due to its similar size and composition, is actually an extremely inhospitable place. Although it is not the closest planet to the Sun, Venus is the hottest, with surface temperatures reaching 465 degrees Celsius. This is the result of a runaway greenhouse effect, where its dense carbon dioxide atmosphere traps the Sun's heat extremely efficiently. Venus' atmosphere is also incredibly thick, with surface pressure equivalent to being 900 meters underwater on Earth. Furthermore, the surface is covered in clouds of sulfuric acid that not only obscure our view of the planet, but also create a highly corrosive environment. These conditions make direct exploration of Venus a significant challenge. The rotation of Venus is another peculiar aspect. It rotates very slowly on its axis, taking about 243 Earth days to complete one rotation, and it does so in the opposite direction to most planets, including Earth. This means that on Venus, the Sun rises in the west and sets in the east, and a Venusian day is longer than a Venusian year. Historically, Venus has been a mystery to scientists. Its intense brightness in the night sky and extreme conditions on the surface have made it a constant target of study and speculation. Space missions, such as the Soviet Union's Venera and Japan's recent Akatsuki, have attempted to uncover the atmospheric and geological secrets of this planet. Understanding Venus gives us crucial insight into how geological and atmospheric processes can transform a planet. These studies not only inform us about Venus, but also shed light on climate phenomena on Earth and other planets. Mars, the red planet, has been the focus of space exploration and human imagination for generations. One of the most impressive features of Mars is Mount Olympus, the largest known mountain in the solar system, measuring about 22 kilometers high, almost 3 times the height of Mount Everest. This giant shield volcano offers a stunning insight into Martian geology and its volcanic history. The surface of Mars is covered in dust rich in iron oxide, which gives it its characteristic reddish color. This dust, combined with global dust storms, can obscure views of the planet for weeks. Furthermore, Mars has valleys, canyons, and craters that indicate a past full of geological and, possibly, hydrographic activity. One of the biggest goals of missions to Mars is to find signs of liquid water. Although water in its liquid form cannot exist on the Martian surface due to low atmospheric pressure, there is evidence of water in the past, such as dry riverbeds and minerals that form in the presence of water. Recently, discoveries of underground saltwater lakes have raised hopes of finding microscopic life forms. Robotic missions, such as NASA's Curiosity and Perseverance rovers, have provided valuable data about the soil composition and climate conditions of Mars. These missions are looking for biosignatures that could indicate whether Mars ever harbored life. Furthermore, the ExoMars mission, in collaboration with ESA and Roscosmos, is expected to launch new instruments to continue this search. Mars is also a leading candidate for future manned missions. NASA and other space agencies are developing technologies that will one day allow humans to explore the Martian surface and potentially establish colonies. The quest to understand Mars is therefore a journey to understand our own place in the cosmos and the possibilities of life beyond Earth. Betelgeuse, one of the brightest stars in the night sky, is located in the constellation Orion. This red supergiant star is approximately 700 times the diameter of our Sun and is about 640 light-years away from Earth. Betelgeuse is so large that, if it were placed at the center of our solar system, it would extend beyond the orbit of Mars. In recent years, Betelgeuse has shown signs that it may be about to explode as a supernova. In 2019, the star began to drastically decrease in brightness, a phenomenon that intrigued astronomers around the world. Although Betelgeuse is destined to explode eventually, this change in brightness is likely caused by pulses on the star's surface or by dust clouds. When Betelgeuse explodes, it will be one of the most spectacular astronomical events observable from Earth. The explosion will be so bright that it will be visible even during the day and could last for weeks or even months. Studying Betelgeuse and similar stars helps us understand the life cycle of stars and the evolution of chemical elements in the universe. In addition to its imminent fate as a supernova, Betelgeuse is a pulsating star, meaning it expands and contracts periodically. These pulsations are caused by complex processes within the star and are an active field of research. Observing these pulsations offers valuable insights into the physics of supergiant stars. The study of Betelgeuse and other supergiant stars is crucial to astronomy. They are cosmic factories of heavy elements which are spread throughout space when they explode as supernovae, enriching the interstellar medium and contributing to the formation of new stars and planets. Neutron stars are ultradense remnants of massive stars that exploded as supernovae. These stars have a mass of about 1.4 times that of the Sun, but a diameter of only about 20 kilometers. The density of these stars is so extreme that a teaspoon of neutron star material would weigh billions of tons on Earth. The formation of a neutron star occurs after a supernova explosion when the core collapses under its own gravity. This collapse forces protons and electrons to fuse into neutrons, resulting in an incredibly dense sphere of neutrons. The gravitational force on a neutron star is so strong that the surface is smooth and any irregularities are crushed. One of the most notable features of neutron stars are pulsars. Pulsars are neutron stars that emit beams of electromagnetic radiation from their magnetic poles. As the star rotates, these beams sweep across space like the beams of a lighthouse, creating regular pulses of radiation that can be detected on Earth. The discovery of pulsars was a milestone in astronomy and opened up new areas of research. In addition to their unique density and properties, neutron stars have extremely strong magnetic fields, billions of times stronger than Earth's magnetic field. These magnetic fields can cause the emission of high-energy radiation and influence the behavior of the neutron star. Studying these magnetic fields helps scientists understand the fundamental forces of nature. Neutron stars are also natural laboratories for testing physics theories. They offer a unique opportunity to study matter under extreme conditions that cannot be replicated in terrestrial laboratories. Ongoing research into neutron stars and their associated phenomena continues to expand our knowledge of the universe. Our Sun, a yellow dwarf star, is the lifeblood of our solar system. Representing more than 99.8% of the total mass of the solar system, its gravity keeps the planets in orbit, and its light and heat make life on Earth possible. Composed mainly of hydrogen and helium, the Sun is a natural nuclear reactor, where the fusion of hydrogen into helium releases enormous amounts of energy. The Sun's energy is generated in its core, where extreme temperatures and pressures allow nuclear fusion to occur. This energy travels through the layers of the Sun, ultimately being emitted as light and heat that reaches Earth. Studying these nuclear reactions in the Sun's core helps scientists understand the fundamental processes that power stars. The Sun has several layers, each with distinct characteristics. The photosphere is the visible layer, while the chromosphere and corona are upper layers that can be observed during a total solar eclipse. The corona, in particular, is of great scientific interest because it is much hotter than the surface of the Sun, a phenomenon not yet fully understood. Sunspots are another interesting feature of the Sun. They are temporarily cooler and darker regions on the Sun's surface caused by concentrations of magnetic fields. The sunspot cycle, which lasts about 11 years, affects solar activity and can influence space weather, impacting Earth in a variety of ways, from the aurora borealis to interference in communications and electrical grids. The future of the Sun is an important field of study. The Sun is estimated to be halfway through its lifespan, with about 4.5 billion years remaining. Eventually, it will expand to become a red giant, engulfing the inner planets, including Earth, before expelling its outer layers and leaving behind a dense core known as a white dwarf. Understanding the Sun's life cycle gives us insight into the evolution of stars and the possible fates of planetary systems like ours. Black holes are one of the most mysterious and fascinating phenomena in the cosmos. They form when a massive star collapses under its own gravity after a supernova. The gravitational pull of a black hole is so strong that nothing, not even light, can escape its pull, hence the name black hole. The point of no return around a black hole is known as the event horizon. Once something crosses that horizon, it is impossible to go back. The singularity, the core of the black hole, is where the density becomes infinite and the laws of physics as we know them no longer apply. This makes black holes a field of intense study and scientific speculation. Black holes cannot be observed directly, but their presence is inferred through their effects on stars and gas around them. When material is attracted to a black hole, it forms an accretion disk around the event horizon. The material in this disk heats up and emits intense radiation, which can be detected by X-ray and radio telescopes. There are different types of black holes, including stellar mass black holes, supermassive black holes, and intermediate black holes. Supermassive black holes, found at the centers of many galaxies, including our Milky Way, are millions to billions of times more massive than the Sun. They play a crucial role in the formation and evolution of galaxies. Black hole research was revolutionized by the detection of gravitational waves, ripples in spacetime caused by merging black holes. These discoveries, made by observatories such as LIGO and Virgo, are opening new frontiers in astrophysics and providing a new way to observe and understand the universe. Dark energy is one of the biggest unknowns in modern cosmology. It is estimated that around 68% of the universe is made up of this mysterious form of energy, which is causing the accelerated expansion of the universe. The exact nature of dark energy is still unknown, but its discovery has revolutionized our understanding of the cosmos. The discovery of dark energy was announced in 1998 when astronomers observed that distant supernovae were further away than expected, indicating that the universe was expanding at an increasing rate. This discovery led to the conclusion that an unknown force, now called dark energy, was driving this acceleration. There are several theories about the nature of dark energy. One possibility is that it is an intrinsic property of space, called cosmological constant, proposed by Albert Einstein. Another theory suggests that dark energy is a dynamic field called quintessence that changes over time. While the exact nature of dark energy remains a mystery, its impact on the universe is undeniable. Studying dark energy is a major goal of several space missions and telescopes, including the Hubble Space Telescope and the upcoming James Webb Space Telescope. These observations are helping scientists map the distribution of dark energy in the universe and understand its role in cosmic evolution. Dark energy research not only helps us understand the expansion of the universe, but also provides us with insights into the fundamental physics and structure of the cosmos. Unraveling the mystery of dark energy could lead to revolutionary discoveries that would change our understanding of the universe and the laws that govern it. Pulsars are neutron stars that emit beams of radiation at regular intervals, like a cosmic beacon. They were discovered in 1967 by Jocelyn Bell Burnell, who noticed repetitive radio signals coming from space. These regular signals led to the identification of pulsars and opened a new area of research in astronomy. Pulsars are extremely dense and have very strong magnetic fields. As they rotate, they emit beams of radiation from their magnetic poles. If these beams are aligned with the Earth, we can detect them as regular pulses of radiation. Some pulsars spin at incredible speeds, completing hundreds of rotations per second. They are valuable tools for scientists. Their regular rotations are so precise that they can be used as cosmic clocks to measure a variety of astronomical phenomena. For example, binary pulsars, which orbit a companion star, can be used to test Einstein's theory of general relativity. Precise measurements of pulsars have helped confirm the existence of gravitational waves. Additionally, pulsars can be used to map the distribution of matter in the universe. By studying radio signals from pulsars, astronomers can detect distortions caused by interstellar gas and dust, helping to map the structure of the interstellar medium. Ongoing research into pulsars is expanding our knowledge of extreme physics and the processes occurring in the universe. They not only provide us with insights into the lives of neutron stars, but also into gravity, magnetism, and the structure of the cosmos. We explore some of the most incredible planets, most intriguing stars, and most inexplicable phenomena in the cosmos. If you like this video, don't forget to like, subscribe to the channel, and share it with your friends who are also passionate about space curiosities. Thank you for watching See the Facts. Until next time, explorers of the cosmos.